Hi, in this video I would like to talk about the ordinary least square estimation. I would first cover the notation and the usual setup, then I'll cover the maths and the mechanics behind it. Here I've written down a simple linear regression equation where yi is the dependent variable and xi is the independent variable. I'll mark it down as true parameters because it is common that we write down beta naught and beta 1 without the hat as true parameters, whereas those with the hat are estimated. The interesting thing about true parameters is that we never know what is the exact value of it. We never know. We can only estimate them. The residual and error term are two different things. We have to be aware of that. How so they are different? We can look at this example here. Let's say the x-axis is experience and y-axis is wage, and we have collected data from workers, and we plot a scatter plot and we put a best fit line. This is the equation of the best fit line. We have the estimated coefficients here. What is a residual? Let's take this point over here. This is the estimated wage from our best fit line, and this is the data that we collected. That is the true wage that the worker is receiving. And the distance between estimated and the true wage that they are getting is the residual. Now, can we know the value of error term? As I said, we never know what is the value of true parameters. We never know what is beta naught and beta 1. We know what are y and x, but we don't know what are beta naught and beta 1, and so we will never know what is the exact value of ui. We can only make assumption about the expected value of ui. And that brings us to the maths and the mechanics of OLS estimation. The OLS based on the logic of minimizing the sum of residuals square. And how do we do that? It is through differentiation. Now, because we are looking for two coefficients, the beta naught and the beta 1, so it makes sense for us to differentiate with respect to beta naught and beta 1. With respect to that, we are differentiating the sum of residual square. And by the rule of differentiation, we can get to this form here. And with respect to beta 1, we can get to this form here. These two are the differential with respect to beta naught and beta 1 hat. And what are the first order condition? The first order condition, as we know, differentiation is to setting the differentials to 0 because we want to minimize this function. By setting the differentials to 0, we're setting this guy to 0 and this guy to 0. So, as I marked it here, 1, referring to this guy, equals to 0. And because this negative 2 has nothing to do with the whole thing becoming 0, so we can get rid of the negative 2 on both equations. And these two equations are the first order condition. It might seem scary, but it's actually just simultaneous equation. We know the y, we know the x, we don't know what are beta naught and beta 1. So it's actually just solving simultaneous equations, just the same as saying solving 5a plus 2b equals to 6, first equation, and the second equation is 2a plus b equals to 2, for example. It's just the same, but this time the unknowns are beta naught hat and beta 1 hat. By solving these two equations, we will get the estimated coefficient of beta naught hat and beta 1 hat. And that is how we get the coefficient. For those who are curious that why first order condition will be sufficient, shouldn't there be second order condition, you might ask? Well, actually, because it's a square that we are operating. It's a function, it's a square. this thing here is a convex function. And some of convex functions are still convex. And we know that setting differentials of a convex function to 0 will guarantee us getting a minimum. And that's why we know solving these two equations simultaneously, we get a minimum value of the sum of residual square. I've covered the simple linear regression case. As a reminder here, that we only have yi and xi. We might deal with multi-linear regression with a lot of other x, but actually the logic is just the same. But this time, the first order condition, if let's say we have x1 and x2, then we will have 3 equations, because this time we will be estimating beta naught hat, beta 1 hat, and beta 2 hat. And we will have 3 equations. It makes sense, because we have 3 coefficients that we have to estimate, and that's why we will have 3 equations. It will be good practice if you write it down for a case of 3 independent variables for your own. Thank you.